All right. We get Barbara to settle down back there. All right. I'm not going to take up any more of his time because I would rather hear him speak than me. So come speak to us, Branyon.
If you would, open up your Bibles to Psalm 19. Psalm 19. We're going to talk about, in tomorrow's lessons in the morning, we're going to talk about, hopefully, some things that you're passionate about. Try to kindle some thoughts and spark some of your thinking of areas of your life and things that you're interested in and how that can connect to God. And so tonight, I want to do the same thing. I want to talk about an area that I am passionate about, that I love, and that is astronomy, things out in the heavens. And so when we turn and we look at Psalm 19, verse 1, the heavens declare the glory of God, and the firmament shows his handiwork. Day unto day utters speech, and night unto night reveals knowledge. There is no speech nor language, for their voice is not heard. Their line has gone out through all the earth, and their words to the end of the world. Notice there the psalmist talking about the heavens, talks about the declaration of God's glory and how that it speaks to us knowledge. When we think about our universe, one amazing aspect of it is the design that we find and how this can point to and show to us God's knowledge, God's understanding for us to have. And I want to start off illustrating it as we think about design and showing a couple of famous paintings. Very likely you know this painting up on the slide, right? The Mona Lisa. This painting painted by the prototypical Renaissance man, Leonardo da Vinci. Living there in the 1400s and early 1500s, Leonardo da Vinci dabbled in just about every type of science or aspect or knowledge gathering. He was also an artist and had wonderful artworks that he gave to the world. And then we also have water lilies. Claude Monet. Claude Monet lived in the 1800s and the early 1900s. He was known as the father of French Impressionism. And so we have these beautiful scenes that he would paint in this impressionistic form, all right? It's not realism. He wasn't gathering and seeing it, but he was painting realistic settings, giving to us, how light is interacting here along the water's surface. Beautiful, beautiful artwork. He did a series that I find very interesting, a series, I think somewhere around 13 paintings called hay bales. Hay bales. He did paintings of bales of hay. It really is just that. But he did it in what they would look like in different seasons, what the hay was like, what the gathering of it, the deterioration of it. And to some degree, he painted it so many times because each time he did, all he captured was that moment, that instant. But nature has so many other time periods, so many other instances that he wasn't able to capture all of it, and so he did it again. And then we have maybe one of my favorite paintings, Starry Night. Starry Night by a post-impressionist painter, Vincent van Gogh, there in the late 1800s, Starry Night. Beautiful imagery, the reflection of across the water. And then we have another one of my favorite paintings, a little bit like a stained glass kind of look, except this really isn't a painting. This is an actual picture, right? This is the Aurora Borealis, the northern lights, right? Sometimes called the dancing lights. Or here in northern latitudes, you see this beautiful light show that dances across the sky, gives to us these greens and blues, sometimes purple hues, as they make their way. And this is a picture from a base up in Alaska, I believe above the Arctic Circle, just beautiful. So when we think about what these paintings give to us an example of effort, of artistry, of intellect, of talent, of skill. And we look at these paintings and we appreciate them. We have them in museums around the world, and we recognize master painters and craftsmen because of what they did. Because when we look at what they completed, what they gave to the world, we can see design. We can see purpose. We can see intent. We can study it. We can seek to understand what they were seeing at that time, what they had in their mind, what vision of the natural world. But when we turn to the natural world, we have the same questions that arise. We can look at the natural world and we think, okay, what is there to learn from it? What's the perspective that we're seeing? Why is it here? What purpose does it serve for us? What purpose does it serve for the ecosystem that surrounds it? What is the flow? What is the skill? What is the talent that we can see? And so I want to look at a few of that as we think about the universe tonight. And I want to think about 4 different areas. Vast, it's structured, it's diverse, and it's detailed. All right? The vastness of the universe, its structure, its diversity, and its detail. Because all of these things independently give to us signatures of design, and when we pull them all collectively, we've got to have a reason, we've got to have a scope that can bring all of it to us, and that points to God. So as we think about the vastness, I want to take a quick tour of our universe, starting with what we know, starting here on earth. And I want us to think just about scale. It's going to be hard. It's going to be hard for me as I explain a few of these images to us tonight. But I want us to think just really about the vast scale of the world that surrounds us. At the smallest scale, bacteria and pollen grains. There on the slide in front of you, you have these kind of beautiful orbs, these almost spherical but very geometrical spheres or globes on this. Those are pollen grains. And then in that little yellow box in the inset, that little yellow box expanded out is a cluster of bacteria. So here we are looking at things, right? The smallest of things that might make us sick, things that might make us sneeze. We don't see them with our eyes. Instead, we've got to have specialized equipment like we talked about in the last session, scanning electron microscopes, tunneling electron microscopes. We've got to be able to see down to smaller than the wavelengths of light to appreciate the scale that surrounds us. But then if we take those pollen grains and we think, well, those pollen grains, they originated from some sort of plant. So here is the underneath side of a sunflower leaf. And as we look at it, we can see that the scale of the leaf is much larger than the pollen grains, right? That on this leaf we have veins and we have structures. We have the flow and the passage of water. We have the respiration of carbon dioxide and oxygen. We have photosynthesis happening, all within just this one fragment, this one piece of one single leaf. But we know that one single leaf comes from some larger plant, all right? The previous leaf was a sunflower. Here we're looking at the canopy of a rainforest, all right? We're looking at massive trees, hundreds of feet tall, all right? We're talking about a place on earth. This one little image is capturing a place on earth that has the highest biodensity on our planet, all right? We're talking about life so dense, so much, even more than what surrounds us. We have trees in the canopy, and then we have the undergrowth. We've got bugs all over the place. We've got birds and monkeys and parrots. We've got more insects and arthropods than we can name, all in this one little region in South America. But what that gives to us is, it gives to us a view that there is a scale of life, right, that we are just grappling with, trying to understand and trying to organize into those kingdoms and phyla and class and order and families and genus and species, just so that we can try to understand how much life there is around us. And all of that life sits on one globe, sits on one sphere, 8,000 miles in diameter, 24,000 miles in circumference. This one globe, right, at this very moment, has over 8 billion people on it, has plants and animals on 30% land, 70% water, rough estimate, right, making up this enormous planet that we call home. But that one planet is orbited by a moon 250,000 miles away. All right, this image was taken by the Apollo 8 astronauts as they flew out to the moon, as they orbited the moon, and instead of a sunrise or a moonrise, they got to see an Earthrise. They got to see the Earth rising above the edge of the moon as their small spacecraft orbited around it. And many of you might have been on planet Earth, having your picture taken from 250,000 miles away. But our Earth and our moon, those are just two bodies, right? But we have a solar system. We have a solar system full of all of these different types of objects. One of those objects, which probably is my favorite, is the planet Saturn. Right there on the screen, you see the planet Saturn and the rings. Now, it looks a little bit different because this is taken from a satellite that was sent out about 20 years ago. It was called Cassini. It was sent to Saturn to orbit and to study and to learn. And this shot was taken when Cassini passed into the shadow of Saturn. All right? So the sun is directly behind the planet Saturn, sort of being eclipsed by it. And what you're seeing is light coming from the sun around the planet Saturn, illuminating the gaseous atmosphere, so you have that ring, and also coming through the rings of Saturn, which tells us that the rings of Saturn are not solid. We knew that, but this is a beautiful picture, right? That shows to us the light reflecting off of all of these thousands of ice particles that are in orbit around Saturn. And that little yellow square in the upper left of the rings, that little yellow square is where we sit. That's our planet Earth. 1 billion miles in the background. And it might be hard to see in the contrast that we have, but there is a pale blue dot right there where that arrow is pointing. A pale blue dot that is being seen. So there is our planet Earth with all 8 billion people on it, all the diversity of life, everything that we just described, sitting 1 billion miles away in our solar system. But our solar system has 8 different planets, numerous dwarf planets full of asteroids, has an asteroid belt between Mars and Jupiter, lots of comets, various meteors and meteorites that will make their way to our planet at different times during the year. But that's just one solar system. That's one star, 8 planets. We sit in a galaxy called the Milky Way. Our galaxy has an estimated 100 billion stars, all right? So just like our sun, this gigantic, large, gaseous object giving off heat and light in copious amounts, we have 100 billion of those in our galaxy, all orbiting around a central region, all right, the core, the nucleus of our Milky Way galaxy. And our galaxy is just one of countless others. You know, the estimates have varied at different times, the number of galaxies that fill our universe. But on that picture on the screen, it's an all-sky mapping. So it's a ground-based telescope that scanned the entire sky at different times, pieced all together into one all-sky view. But then they went in and they removed all the foreground stars. So every dot that you see inside that kind of blue ring, every dot you see is another galaxy, like our Milky Way, full of stars and gas and dust, gravitationally bound together. So in just a quick snapshot, we went from the microscopic, less than the wavelengths of light that we can't see with our eyes, to the distant galaxies that our kids will still be discovering after us. Our universe is vast. And so the question has to come, has to be addressed. Where did this all come from? Where did we get such a vast universe? When we think about our universe, we talked about it already, but a second aspect of design is the fact that it's not just a bunch of stuff, right? We're not just sitting here in some sort of random orientation and some sort of chaotic arrangement of atoms and some sort of chaotic arrangement of bodies floating through space. No, we have these laws of nature, like we talked about in the first session, that give to us this order and this function and this process, and that we live and we thrive, and we have these structures that surround us. And so not even just thinking about the scale, but just thinking about what structure we see. We have these amazing planets and objects in our solar system that operate and orbit under gravity. We have these amazing planets like Saturn and the rings. We have an incredible sun, right? Our sun, one single star, but you know what? It's got an atmosphere also. It's got a magnetic field also. It has nuclear fusion, we believe, happening at the core, creating all of this energy flowing out of it. Even particles called neutrinos that interact with matter in a really bizarre and fantastic kind of way, all coming from this one structure, right? Organized, set up, functioning, so stable that we don't have to worry about it. It's not going to explode. It's not going to wipe out our planet Earth. It is sitting there functioning and providing heat and energy and light to our planet. And we think about out in space how much diversity there is. And we've already talked about some of that diversity, asteroids and comets and planets and dwarf planets and stars and galaxies. But where did we get this diversity? How do we have such vast, such structured, such diverse systems? When we think about some of the stars and some of the diversity that we have in our universe, we have here on the screen is the constellation Orion. All right, probably one of the most recognizable. You go out sort of in the winter time, so we're getting close to the time that in the early evening, when you go out, there'll be 3 bright stars rising in the east, heading their way across the sky to the west. 3, all nice, very straight line, and that's Orion's belt. In Job, we have this verse where God speaks to Job, and he says, "Can you bind the chains of the Pleiades or loose the cords of Orion?" You see, God said, Job, there's objects in the sky. There are things that you see with your own eyes that you recognize. Where did they come from? Do you have control over them? Do you guide them? Do you describe where they went? No, because they are so much farther, so much bigger, so much beyond where we are. They point to God. Can you lead forth the Mazzaroth? That's the constellations in their season. Can you guide the bear with its children? That's a reference to Ursa Major and Ursa Minor. Do you know the ordinances of the heavens? Can you establish their rule? When we turn to the New Testament, so that's God using apologetics, using Christian evidences, using evidences for His own sovereignty and supremacy. And when we turn to the New Testament, there's an interesting statement that Paul makes in 1 Corinthians chapter 15. He says there's one glory of the sun and another glory of the moon and another glory of the stars. For one star differs from another in glory. If I go back to the previous slide just real quick, the constellation Orion is this beautiful representation of the diversity in the heavens. You see, in this one constellation, we have a red giant. We have a star called Betelgeuse, or Betelgeuse, that is hundreds of times, thousands of times bigger than our own sun. If you were to place it inside our solar system, it would consume all the planets out to Jupiter. Yet, it's cooler than our sun, 5,000, 4,000 degrees on its surface. Gigantic, but it's red, so it's giving off its wavelengths of light mostly in the red. In the foot of Orion, there in the bottom right, is a star called Rigel, and that star is 10, 20,000 degrees at its surface. It's a giant star, not as big as Betelgeuse, but it's blue. It's this white, blue, hot star burning very, very rapidly, giving off lots of radiation in the ultraviolet. And so we have this diversity that Job saw when he recognized Orion, and what Paul, when he's talking really in spiritual terms, the difference between the carnal and physical and the spiritual body, our fleshly bodies and our soul, he references the stars and he says, look, there's one glory of the sun, one glory of the moon, and another glory of the stars, and the stars differ in their glory. Today, in astronomy, we have sort of understood and appreciated even more what Paul was referencing that to the church at Corinth was understandable. They could look at Orion, they could look at the constellations, they could start to make this distinction of how diverse the heavens are, how different the glory is between these objects. But today we have this chart that's on the screen. It's called the HR diagram. And this diagram was developed to try to understand how many different stars there are in our universe. How there are giant and supergiant stars at the top of that chart. How there are dwarf objects, sometimes called dwarf stars, white dwarf stars, neutron stars, that would be at the bottom of that chart. And how 90% of all stars fall along the main sequence, which is that diagonal that runs from the blue to the red. And how that region where our sun is very, very stable. Those stars are undergoing equilibrium processes, all right? So very long-lasting. So we can understand just a snippet of the diversity that exists around us, even that Job and Paul wrote about when they tried to explain God's glory. And then here's just a quick diagram showing that in our universe we have this huge diversity even among the galaxies. We have galaxies that are spherical, called elliptical galaxies, and then they begin, different ones have different shapes, moving towards maybe a football shape. Right there in the middle, we have these elliptical galaxies becoming flatter and flatter. And then we have galaxies that kind of like our Milky Way, which are spirals, right? These beautiful spiral arms circulating around a nucleus on this flat plane. But the problem is that Edwin Hubble came up with this diagram for this new object that he was discovering. They weren't nebulas, that's what they used to be called. They were actually galaxies outside of our own. And so he tried to understand how diverse it is. But this is kind of what the chart looks like today. Because when we look out and we appreciate and we explore God's creation even more, we see how incredibly diverse it is, even beyond what we originally thought. We have a vast universe that has this enormous number of structures that is so incredibly diverse, but yet it has amazing detail. This is an image called the Hubble Deep Field. In the early days of Hubble, at the end of the 90s, they decided to take an image, a very long exposure of a part of the sky they had no object documented, cataloged to exist. So they chose this one small spot in the sky, and they set Hubble viewing it for 1 million seconds to see what it would see. After the 1 million seconds and the data came back and they began to process it, this is the image that they got. This image, I think, has one star on it. One star. Every other object in this field is a galaxy. This field has about 10,000 galaxies. If you were to take this small field and say, if that is representative of the rest of the sky, then we are talking that we need to multiply that by almost 13 million times. So it's 12.7 millionth of the entire sky is on this one single frame. And so we're talking an estimate of 130 billion galaxies. You know, in astronomy, sometimes it's asked, how many stars do we have? How many galaxies do we have? There's no way to count them all. There's not a catalog that has them all. We don't have it The best we can do is take a snippet, take a survey, count it up, and say, what would that be in the rest of the sky if that was the same? And so this is where we get some large number like this, which we don't necessarily know. But there's some incredible detail in our universe. Detail like supernova remnants, like the Crab Nebula, which you see here, that has a pulsar at the center of it that pulses many, many times per second. That's a star rotating multiple times in less than a second, giving off radio emission. I go back to some of these, and we think about the detail and what God talked about. This is the constellation Orion in a visible light. It's what we might see, right, minus the lines in the sky. But if our eyes could see maybe a little bit more detail, say if we could see the infrared, this is what the constellation would look like. The entire region of Orion is this enormous nebula complex. All of this gas and dust that exists in various structures and various forms, giving off different wavelengths of light. And that's what really makes our universe even more amazing, is that everything that we see and that we can be amazed by can be multiplied by every other form of light or radiation. We have a galaxy in visible light, but that galaxy can be imaged on the left in infrared, in the middle in visible. It can also give to us an X-ray view. So our universe has this detail in gamma rays, in X-rays, in ultraviolet, in visible, in infrared, in microwave, in radio waves, all giving to us different aspects, different images, different objects that exist in our universe. We have our fabulous Milky Way galaxy. We have the spiral structure, which we sit inside the Milky Way, and really we just know the spiral structure because when we image the entire sky, we can map out where all the stars are, and we see that they all exist in this plane. So there on the image, that all sky view on the bottom is the whole sky, okay? And all of the stars, we can see there's a density that line up in a linear fashion, and that tells us that we sit in a galaxy that is a plane, is a spiral. And so we look at it and we ask the question, when we just think about how amazing our universe is and what surrounds us, that we have to have an answer for these characteristics. And what we see is our universe is vast. It is structured. It is diverse. It is detailed. If we were to see that in man-made structures, if we were to look at the tallest building in the world, how vast it is, if we were to look at Hoover Dam, if we were to look at the Grand Coulee Dam, the longest, if we were to look at some of these enormous structures that are just in size are large, it tells us that there's something behind it, right? That their existence, that their presence, that their design needs an answer. If we look at how well they are built, the structures that are built to survive earthquakes and hurricanes and tsunamis and other natural forces, and we think about the structure, we would need to appreciate and understand that somebody thought about those things, that we're thankful that they thought about putting those aspects and elements into the structure. You know, just the basics of our own home, right? We are thankful that the builders, that the engineers, that the electricians, that the plumbers, that all of this thought and understanding went into the purpose of this structure. But you know, all of our houses are different. We have this diversity. Buildings across the world are different. You have this diversity. And we have all these details accounted for. And so the question comes, in our everyday life, when we see these things, we attribute them to design. But when we attribute them to design and we go, you know, these phones that we have in our pockets that we carry around with us that can do so much, that can communicate and bring to us so much information, when we say, hey, this is a great phone by Apple, this is a great phone by Samsung, recognizing design doesn't stop you from using it. You see, there's this thought, and we talked about it a little bit in the first session, that science and faith are separate, that people who are religious, they only bring God into the conversation when they don't understand, when there's a gap in their knowledge. It's called God of the gaps. You only talk about God or invoke God because you don't understand. But that's not the case. We can look at the world around us, and as scientists, we can say, God designed this. Because that doesn't stop us from studying it, from taking out our telescopes like my wife and I did this last Thursday at the Buda Public Library. And we show people Jupiter. And you can see the bands and the moons of Jupiter and the rings of Saturn. It doesn't stop us from using microscopes to study things on slides and understanding the human body. Recognizing design doesn't stop what you do, but it does guide what you do. It gives to you a purpose. It gives to you a fact that you're trying to uncover the element of design, the purpose for what you're seeing. And so the question is, did you see the fingerprints of God? Can we recognize that when we see the hallmarks of design and intelligence in our planet, in our solar system, that those hallmarks of design demand a designer? The Hebrews writer said that every house is built by someone, but he who built all things is God. Scientists can say the heavens declare the glory of God and the firmament shows his handiwork. And then we can continue to study to find out what is the handiwork that he put into place. How does it operate? How fascinating is it? You know, sometimes I'm asked the question of, should we go into space? Right? Right now, the space race or that idea is coming back into modern culture, right? We've got SpaceX and Blue Origin. We've got Russia going and China going, and we're trying to launch Artemis 1 right now, right? We're trying to get back to the moon. And so it's the question of, well, you know, should we do these things? Well, I say yes from this perspective, that when we push the boundaries, we gain new knowledge. When we gain new knowledge, it tells us more about God's creation and things that happen in it. And when we get to Mars, and the fact that we've got to carry all of our air, all of our water, all of our food, we've got to have heat for negative 100-degree temperatures, we will appreciate how our planet Earth is designed for us so well. So let's get all the scientists, let's get everyone and go out to these places so that we look back and have a perspective that we can appreciate and recognize God's design, because we thrive and we're taking it for granted. I hope that encourages us to think about God in our everyday lives. Tomorrow morning we're going to talk about Christian evidences for every Christian, and I hope that you'll be here because I want to put my passion for astronomy, which may not be your passion, and that's perfectly fine. But tomorrow I want to talk about what your passion is, what is in your life that connects to God, and how you can use that to raise your children, how you can use that to connect with your neighbor, how you can use that to point people to God, because that's exactly what the psalmist said when he said, when we use these things and we talk about the heavens, they will declare God if we allow them to. So I hope that's an encouragement for you. If you need anything, Patrick will be coming up here. You can ask him about it.
Said this during that presentation, but I remember muttering several times, wow. Just to consider it, and to consider that God is the creator of those things and designer, and he thought those things about those things. It's just amazing to me. I appreciate Branyon and the 2 lessons tonight. I look forward to the 2 tomorrow morning, starting in our Bible class time. Also, for those who will be coming with us, or if you want to invite someone, don't forget we have the potluck And then right after that, Branyon will have the devotional for us and sort of wrap everything up, I guess, and I'm looking forward to that as well. Elders, are there any announcements I need to make? We're good? Jeff, will you lead us in a closing prayer?